Geometry. What's poppin'? This is Mr. Terran rocking with you today, and we are in the last part of Chapter 12, Transformations in the Coordinate Plane, and today we're talking about dilations. Dilations. Sometimes you can think about it as a stretch. I think earlier I used the example, a dilation is like when your eye, like your pupils in your eyes might stretch. Okay, so that's kind of what we're going to be looking at today. One important thing to note is that in the previous three, those were called rigid transformations, which means the shape didn't change at all. Like whether it was a triangle, rectangle, trapezoid, whatever, the shape and size of the shape stayed exactly the same. It was just moved around. And so everything we did with those rules was always plus or minus a number. Today we're going to be stretching things and shrinking them, so we're actually going to be multiplying by a number, and I'll get into that. But before we get into anything else, let's get my ugly mug out of here and let's pin this PowerPoint back up on the main stage and let's get after it. So, dilation, we kind of just talked about what that means. It's just when something stretches or shrinks. All right, so again, let's take a look at a couple pictures here and try and figure out what a dilation is. Definitely not. I don't even know what. That's not any sort of transformation. B looks like a dilation, though, because notice the shape of the triangle staying the exact same. It's just enlarging. For part C, that wouldn't work. That's not even the same shape. But D would also be a dilation. It looks like we're taking this pentagon and we're just shrinking it. All right, so dilation is just stretching or shrinking. Okay. So every dilation we talk about will always have a scale factor, and all you need to do is you just need to multiply your x and y value times your scale factor, and that is it. That is it. So if you notice on my picture here, to go from my pre-image point P to my image P prime, notice we're just taking a scale factor of k and multiplying it by my coordinates. Just k can be any number, and we're just multiplying. So, for example, dilate these points. So if I have a point at 3 comma negative 2, and I have a scale factor of negative 3, all I want to do is take my original coordinates and multiply it by my scale factor. So 3 times negative 3 and negative 2 times negative 3. And that will give me, well, 3 times negative 3 is negative 9, and negative 2 times negative 3 will give me positive 6. So literally all we're doing is we're just multiplying our coordinates by our scale factor, and that's it. That will bring us from our pre-image to our image. So right here, scale factor is 1/4. If you want to do this as 0.25 in your calculator, you can. But if I do negative 4 times a quarter, that's actually going to be negative 1, and 12 times a quarter is going to be 3. And if you don't believe me, just go ahead and throw it in a calculator. All right? Not too bad. And this is actually a pretty short PowerPoint. It's only a few slides. We're not going to get into compositions of transformations in the coordinate plane because it's the end of the semester here, and we just won't have enough time. But notice right here, dilate using a scale factor of 1/2. So again, the same steps we've been doing this whole chapter. Start by plotting your points, your pre-image. Apply whatever rule you're applying. This time it's dilations with a scale factor, and then plot your image. All right. So let's do our pre-image here in black. Just scoot this over here. So A is at 2, negative 2. 2, negative 2 is right there. B is at 2, comma 3, so right up here. C is at negative 3, comma positive 3, so right up here. And D is at negative 3, comma negative 2, so right there. So it looks like we got a nice little rectangle here. I almost feel like I'm the Bob Ross of geometry, drawing little sketches. If you don't know who Bob Ross is, that's okay. All right, so let's apply our scale factor of 1/2. So timesing something by 1/2 is the same as dividing by 2, but remember it's always, our rule was if we're given a preimage of x comma y, it's kx times ky. So I'm just timesing my coordinates, in this case by 1/2. So 2 times 1/2 would just be 1. Negative 2 times 1/2 would just be negative 1. Again, 2 times 1/2, or 1/2 of 2 would be 1. 3 times 1/2 would be 3 over 2, or 1.5. We just did 3's over here, so that's going to be negative 1.5, positive 1.5, and then this is negative 1.5, and then negative 1, right? Because we're doing halves. So if we do this correctly, everything should look pretty nice and neat. So let's plot these. 1, negative 1, it's going to be right here. That's A prime. B prime is at 1, comma 1.5, so 1, comma 1.5 is going to be right up here at B prime. C prime is going to be negative 1.5, comma 1.5, so right here in the middle. C prime and D prime, negative 1.5, negative 1, so right here. D prime, let's connect. And there is our image and our pre-image. All right? Okay. Not too bad. Last one, and this is actually the last example for this entire unit, so make it a good one. If you want to pause the video, pause here, see if you can do this on your own. And then go ahead and unpause, and you can check and see your work. If you're still struggling, no worries, let's do it together. First thing I'm going to want to do is, let's just plot these in green this time. I want to plot D, E, and F. So D is at 0, 0. That's going to be easy enough. E is at negative 1, comma 0. And F is at negative 1, comma negative 1. So that's a very easy looking triangle here. Very small, unfortunately. Our scale factor is now negative 2, so I'm going to multiply everything by negative 2. So 0 times negative 2 is still 0, right? So it's going to be 0, 0 for both. Negative 1 times negative 2 would be negative 2. This will still stay at 0. And negative 1 times negative 2. Sorry, this should be positive 2. My bad. Positive 2, right? A negative times a negative obviously is a positive. So negative 1 times negative 2 is going to be a positive 2 here and a positive 2 here. Let's do this in pink again. So 0, 0 is going to stay right here. So D prime will share a point with D. E prime is at 2, comma 0, so right here. And F prime is at 2, comma 2. So notice it did get a little bit larger. All right. Compositions of transformations, we're not going to do this time around, but that's pretty much it. So if you think back, let's summarize. We've done first thing we did is reflections, then translations, then rotations, and finally dilations. Remember, reflections, translations, and rotations are all rigid motion. The shape doesn't change. Dilation is the only one that changes the shape. That's all I got. Remember, if you guys have any teacher or any questions, shoot out an email to your teachers. It's been a pleasure working with all y'all. I hope these videos were helpful. Taryn out.